Hey, today we are going to talk about uh, what, why we want to learn the Hadoop or Spark. So before going to talk about Spark, so let's talk about the earlier history of the big data and what are the existing frameworks and what exactly these frameworks is solving or etc. Some of the brief 15 to 20 minutes discussion before going to talk about all the earlier histories. Okay, let's go into let's say let's talk about, let's say this is an organization. So for every organization, the employees, the workers, right? So basically the amount of data which is being generated for an organization by an employees. So here the workers will signed up, workers will register and they will generate data for an organization. The employees of an organization generating the data. I'm just taking an example, how the data is being generated by employees or by some external systems or by any other business networks or etc. Let's talk about certain phases of what's happening for the first 15 years or something like that. How the data is evolving, in different phases. That's where I'm looking at it. So this is one of the first progression. The workers of an organization is registered and continuously generating the data. The amount of data which is being a very limited data. I can say it's in terms of gigabytes or something like that. So if I really want to process this limited data, basically what exactly there are two things, the organization where the amount of data is being generated. So basically there are two things which we need to focus. One thing is how the data is being processing it, and this is the one of the phase. So the first phase is where we need to process this data, and the second phase is once we process the data and we have to store that particular data, right? So this is this is where we need to process it. So what we need to observe here is, so whatever the data which is being generated by an organization is very limited, and I can easily process it and I can able store it. This is one of the progression. And in the second case, let us take the users. In the second progression, I'm taking the users of any of the social networking users, or any of the business networking the users, or any of the internet users, or whoever it is. So basically the users signing up themselves, they keep entering the data. The amount of data which is being generated by these websites or social networking sites or any of the other the internet related, so the amount of data is is higher. The order of magnitude is also higher. So if you compare in the progression, the employee of an organization, the data which is being accumulated is lesser than the data being accumulated by the users. Here one thing, employees of an organization generating a data, the users generating around the data. The comparison of progression 1 and comparison of progression 2, in the progression 2, the users generating around the data, the amount of data being accumulated is higher than the amount of data which is being generated by in the progress, the workers, the employees of an organization. So what we need to observe is, in the first phase, the data being generated is very limited. In the second phase, the amount of data is little higher than the progression 1. So it means that the order of magnitude is also higher. The data is growing in the phases wise. Let's take another progression, another phase. So I'm taking another phase let's talk about, I will take in like this, so assume that this is the phase 1, and this is phase 1, this is progression 2, and this is progression 3. So in the progression 3, the best example is if you look into any of the rocket where the best example is in the science experiments, or especially the rockets, or the satellites which are revolving around the earth, and the CC cameras which are monitoring continuously the cities, or banks, and the machines, the ATM machines or smart meters, or there are bunch of machines which are generating. The amount of data is being generated, accumulation is really very, very high. Those are generating massive amount of data. So the order of magnitude is really very, very high. So it's scaled up. The amount of data is beyond the limits. Yes, so if you compare progression 1 and progression 2 and progression 3, so in the phases, the amount of data is being generated is rapidly growing like anything. So how can we handle this data? How we can able to process this amount of data, this massive amount of data? How we can able to store the data? Where we need to store it? That's the biggest question. Let's take an example. As I said, let's take in the olden days, what exactly we will do is, especially in the traditional database systems. So the best example is RDBMS, Relational Database Management System, where we can able to manage the data, and we can able to process it, and we can able to store it, right? So in the olden days, so what exactly we will do is, so basically this is the where the data is storing. If let's say the data maybe in 1 GB or something like that, 1 GB of data. So basically I want to process it. So in the traditional database systems, what exactly we will do is, I want to process 1 GB of data where the data is stored. Basically what I will do is, I will fetch the data onto my local CPU. I can able to process this data. I can able to process this data, right? Because so in the local machine I have a sufficient space, so I can easily fetch this data and I can able to process it. Since the amount of data, whatever which is stored is very limited, I can easily able to process it. I can able. So what we need to observe is, here what exactly we are doing is, we are bringing the data to the processor. We are bringing the data to the processor, right? So then it's fine, because the data is limited. I can able to fetch the data, I can able to process it. Since I can able to fetch it to my local machine, I can able to process it because the data is very limited. Now if you look into the big data systems, so the amount of data which is being generated, it is in the form of petabytes or terabytes or zettabytes, exabytes. It's the data is very, very high. So I want to process it, petabytes of data. So I want to fetch it to to my local machine, I want to process it. So my local machine capacity is very limited. So how can I process this huge amount of data? The amount of data, whatever I'm trying to fetch, it's overwhelming, right? So can it be possible to process this data? So what we need to observe is, here in the first case, we are bringing the data to our local machine, we are able to process it. Now the second case, the data is very higher and I want to process it. I'm going to fetch the data, I'm trying to process it. But my processing capacity is not supporting to process this huge amount of data. So what exactly it's locking here is, I am unable to processing it because it's overwhelming, right? So what we need to observe is, as the moment the data is growing higher, when I really want to process this higher data, my traditional database processors are unable to handle it. So the processing capacity is reducing. The moment data is growing higher, the moment data is scaling up, the processing capacity is reducing. So how can I solve this problem? That is one of the key area which we need to focus it. So in this case, what exactly we have to do is, this is the processor, my local machine. These are the data centers. These are all the bunch of servers which are in the data centers. This is the data center. Now, this is the processor. So in the early case, what we are doing is, we are taking the data, we are fetching the data to the processor. So in the second scenario, basically what we are doing is, what is the problem here is, when the data is increasing, I am failed to process that huge data. So I want to increase the processing capacity. How can I improve it? So basically what I am doing is, in the first case, I fetch the data, I brought it to the CPU where I am processing it. In the second case, I am bringing the processor. I can bring infinite number of CPUs to the data center, where you can able to find a bunch of rows where we can see bunch of servers which are in a parallel, which are in a proper rows. If I really want to process this huge data, this data I can able to place this chip onto the each server. I can able to process this data, and every server has this processor. Every server has a processor. So if I really want to process this huge amount of data, for me it's a very easy if I bring all the infinite number of processors and place it in the server, because servers where we can able to process parallelly in order to process this data. So now data is growing higher and the processing also growing higher. So order of magnitude of the data is growing higher, and the order of magnitude of the processor is also growing. So it means that I am able to process the huge amount of data. That's where the technological shift. That's what we want. The moment data is growing higher, I am failed to process the data in a traditional approach. But now the case is, what I'm doing is I'm bringing the infinite number of processors to the data center, where we can able to see bunch of servers which are placed what is in the cluster, right? Everyone knows about what is the cluster, right? The cluster is, a bunch of nodes, the bunch of servers which are helps to process the data. So whatever the data, it will decompose into multiple machines, and those will be processed parallelly. That is called parallel processing, right? I hope everyone understand what I explained so far. Just I'm doing a small recap here. The first point is, so what we discussed is the employee for an organization, the amount of data which is being is very limited, and the users generated around the data. The best example for the users signing up for the social networking sites, where they're generating around the data, the amount of data which is being generated, the order of magnitude is little higher than the progression 1. And the third case, in the third progression, where the machines which are generating is the massive amount of data. So I'll give examples like the smart meters or satellites revolving around the earth, the CC cameras which are monitoring continuously the buildings or cities or banks, etc. So the amount of data is really very, very high. Order of magnitude is very, very higher. So what we have to observe here is, day by day the data is growing very high. So the traditional database systems are failed to process and handle this huge amount of data. And at the same time, the traditional database systems are can handle only structured data efficiently. But if you look into these different progressions, the amount of data which is being generated, different kind of data, it might be a structured data, or it might be a unstructured data, or it might be semi-structured data. It might be XML format, or it might be JSON format, or it might be a video format, or it might be any of the static contents, audios, or the satellites, whatever the generating improper data, whatever it is, it's the data is different kind of formats. So who is responsible? How does the relational database systems really helps to solve these problems? Definitely those are not. That's where the technological shift will came into picture, in order to improve the processing capacity to solve or to process this huge amount of data. So that's where the system came into picture. The big data is the buzzword, will become very, very popular nowadays. Okay, let's talk about what exactly we are doing the big data systems. Let's take about any of the systems. Basically what we have to observe, there are two things, as whatever I discussed in the elite scenarios. Any of the system which is being generating the data, and once the data is generating, and we have to store it. The generated data, we have to be processed it, and we need to store it. So processing is one of the key, and storing is one of the another attribute. So there are two things which we need to observe. One is processing and the storing. So for the processing purpose, there are so many programming model which is introduced, and the another new framework, Hadoop is one of the framework which helps to process this huge amount of data parallelly, and which also supports runs on the commodity softwares, and parallel processing where it supports in order to process this huge amount of data. And once data is processed, obviously we have to store the data, right? So for that, the Hadoop introduced the file system called distributed file system, Hadoop file system, where the data is stored in exactly that we can call it as a HDFC, Hadoop distributed file system. So that's where data will be stored, and for the processing purpose, they have the paradigm programming code called MapReduce. So this is one of the popular to process the data and in order to do sorting and shuffling the data. For that they use the map reducing, and then for the storing purpose they use the HDFS. So this Hadoop distributed file system and the map reducing, they introduced in the Hadoop framework by Dowkate, and because the cutting edge for this is the Google, obviously, because Google will published a paper on this map reduced file system and Google file system. Based on that, the published paper, which is implemented by Dowkate, based on that paper, that they named it as Hadoop distributed file. That's where the Hadoop, Dowkate is introduced these file system and map reduce programming. So those are helps to process this huge amount of data and store huge amount of data. That's one of the key areas which we need to observe. So when you look into the current one which we are talking about, Apache Spark, first of all, why we should go for the Apache Spark and rather be already having the Hadoop distributed file systems and Hadoop frameworks which are already introduced different versions, Hadoop 1.0 and Hadoop Yarn second 2.0, and they released so many features, and at the same time they have so many tools, Hadoop ecosystem. For the processing purpose or to perform the queries, to execute the queries, to handle all the unstructured data or semi-structured data. They also introduce different kind of NoSQL databases, especially as I said, there are so many NoSQL databases, something like MongoDB or Cassandra, HBase, Redis. There are so many, plenty of NoSQL databases to store this data. And Hadoop ecosystem, where it supports different kind of tools like Scoop or Oozie or Zookeeper, Hive, Peak. So every ecosystem tool will helps to solve a particular problem. The best example is if we really want to transfer a data from any of the terminal database or DBMS to big data systems, Scoop is one of the tool, and we can able to do from HDFS to the traditional database system, or a traditional database system to the big data systems. So there are certain tools, and if you take an example for a Hive, Hive especially in order to do all the analytics, to like our RDBMS Oracle, how the SQL structured query language helps to solve processing these queries and executing these queries, etc. Where the Hive also one of the ecosystem for Hadoop to process to execute similar kind of Hive queries. And similarly, the Pig is one of the other scripting, where we can able to perform all these analytical kind of things. Another one is the Zookeeper, where Zookeeper is something like coordinator service is the one of the tool in order to handle all this cluster management and coordination, etc. So like that, there are plenty of ecosystems which are available in order to perform. Oozie is another one, which is workflow management, because there are multiple phases, for every phase we have to be executed in a sequential way. For that, the workflow is required. So for that, Oozie is one of the tool, so similarly, so there are plenty of tools which are available in the market, and the Hadoop is introducing. So that's fine so far. And coming to the Apache Scoop, and basically Apache Spark is one of the data streaming tool, and which helps to solve near real-time data streaming problems. And also the Spark, where it supports another algorithm called RDD, resilient distributed data sets. We will discuss slowly one by one what exactly the RDD, and the other two operations are transformations and actions. So Apache Spark helps, and also it supports for in-memory computing algorithm, which helps to process the data more efficiently comparing with the Hadoop. So if you look into the data processing, the processing capacity is really very higher compared with the Hadoop. So why is it so? That's one of the key things which we are going to read it. So Apache Spark, and another question is the Apache Spark is really the replacement of Hadoop? Yes or no? If someone asks me the same question, basically no. There are two, as I told you, the two scenarios. One is processing and storage. Here, what exactly we have to observe here is we are improving the processing speed. That's where, but basically this is not the complete replacement of the Hadoop, because eventually even the Spark, where we are storing the data in the Hadoop distributed file system, that we need to observe. So to improve the speed processing and the computation, so Apache Spark is 100 times faster when you run on in memory. When you run on the disk, it is 40 times far better than the Hadoop. So there are some of the techniques which we need to identify, and similarly we have something like iterative and interactive processing. That's where data serialization and data input and output operations and data replications, where it really makes the system very slow, especially in the MapReduce programming, right? So basically when you really want to process certain data set, right, what exactly, first we need to read it and we need to place it, and we need to write it to the disk, and from where again you need to read it, and like that there are different phases. So for every phase, the number of input output operations and number of data serialization and replication, it's really drastically reduce the system performance. It's really makes the system very slow. So how can we solve this? So that's one of the key thing. That's where the Hadoop really which maintains the in memory to perform all these computations, and those we will discuss one by one. And there are Apache Spark, where it has different kind of modules, something like Apache Streaming, Apache Spark SQL, and Spark glib and Scrap graphics. So each library module have their own individual purpose. For the graphs, just especially if you really want to process any of the graphical what we say yeah, the best example is this one. So if you look into the Apache Spark, where you can see the right Spark SQL streaming, machine learning on graphics, etc. So there looks like there are different 4 modules. So each module have their own individual purpose. Machine learning, mlib for machine learning, and Spark SQL for to process unstructured data, GraphX for graph processing, stream processing for live data streams, etc. So these we will read one by one. And first of all, we need to be identify what exactly the benefits of the Spark, why and at the same time what is the iterative approach and interactive approach, and what are the benefits we can achieve if you use the Spark, and what is the internal architecture of the Apache Spark, what is the Apache Spark core engine, how this is related to the Hadoop. Does this Hadoop framework will be really still we are using merging with the Spark? Oh, there are plenty of questions which are revolving around us. Those we will continue in the next session. Thank you very much for your patience.